This is how to wire PLC inputs and outputs. The whole field wiring picture on one sheet. Field devices come in on the input side. Loads go out on the output side. A 24-volt DC supply feeds both, and a common terminal ties each bank together. Let me rewind and wire every terminal from scratch, then draw one live. So what is a PLC's I/O, really? I/O just means inputs and outputs. The terminals where the PLC meets the real world. The processor is a tiny low-voltage brain. It never touches a motor or a main circuit directly. It only reads inputs and sets outputs. On the input side, you land field devices that tell the PLC what is happening, a push button, a limit switch, a proximity sensor. Each one drives one input terminal high or low. On the output side, the PLC switches loads, a contactor coil, an indicator lamp, a solenoid valve. The processor decides, the output card does the switching. That is the whole job of the I/O card. Sense the world on the inputs. Act on the world through the outputs. Everything we wire from here hangs off that one idea. One quick note before we go on. Everything I draw here is in a free browser editor. No install, no sign up. It is at CircuitDiagramMaker.app, and the link is in the description. Open it and draw along. Start with the two things every I/O wire depends on, the field supply and the common. The field power is almost always 24-volt DC. One supply, a plus rail and a minus rail, and it powers both your input devices and your output loads. Now the common. Each bank of inputs shares one common terminal, and each bank of outputs shares its own. The common is just the return path. The other end of every field circuit lands there. Tie the input common to one rail of your 24 volts, and every input switch only has to bridge from that rail to its input terminal. Get the supply and the common right first, and every input and every output after it is just one more wire. Get the common wrong, and nothing reads and nothing fires. Now the digital inputs, the simplest field wiring there is. A digital input only ever asks one question. Is there 24 volts on this terminal? Yes or no? On is a 1. Off is a 0. So a push button wires from the plus rail through the button into an input terminal. Press it, the terminal sees 24 volts, the PLC reads a 1. A limit switch is the same. A lever trips the contact, the input goes high. A simple 2-wire proximity sensor drops in the same spot, closing the path when metal comes near. And a return? Every one of those devices shares the input common. Supply on one side, input terminal in the middle, common on the other. That is a digital input, start to finish. Here is the one thing that trips everybody up. Syncing versus sourcing. It is just which way the current flows through the input. Picture the current as a loop. In a sourcing input, the field device sources current into the terminal. Current flows from the plus rail through the device into the input, and the input common goes to the minus rail. That is a PNP sensor. It pushes the positive down the wire. Flip it around for syncing. The field device syncs current away from the terminal. The input terminal supplies the current. It flows out through the device, and the input common ties to the plus rail. That is an NPN sensor. It pulls the current back to minus. Same switch, same 24 volts. The only difference is the direction of the loop and which rail the common lands on. Match the sensor to the card. A PNP sensor needs a sourcing wired input. An NPN sensor needs a syncing one. Get it backwards, and the input never sees the signal. Now flip to the outputs, where the PLC does the switching. There are 3 kinds of output, and the type decides what you can wire to it. First, relay outputs, a real mechanical contact inside the card. Dry contacts, AC or DC, either polarity, and they handle a decent load. Slower, and the contacts wear, but the most forgiving. Second, transistor outputs, solid state, DC only, and you must watch the polarity, sourcing, or syncing just like the inputs. No moving parts, fast, and they last for millions of switches. This is your choice for high-speed pulsing. Third, triac outputs, solid state for AC loads only. Great for switching a mains contactor coil or a lamp. No contact wear, but never wire a triac output to DC. So before you land a single wire, read the card. Relay, transistor, or triac. That tells you the voltage, the polarity, and the load it can carry. Now wire an actual load onto an output. Take one output terminal. From it, run through your load, a contactor coil, a lamp, a solenoid, and back to the field supply through the output common. The PLC closes the output. Current flows through the load switches on. Same loop as an input, just the PLC is the switch now. One thing you must not skip. If the load is inductive, a coil or relay is solenoid, it kicks back a nasty voltage spike the instant the output turns off. That spike can destroy a transistor output, so you protect it. Across a DC coil, wire a flyback diode, a plain diode reversed across the coil, and it swallows the spike. On an AC load, use a snubber, a small resistor and capacitor across the contacts. Cheap parts, and they save the output card. Here is a real PLC panel wiring diagram, open straight in the editor. Everything we covered is on one sheet. The field supply, the input terminals with their devices, and the input common. The output terminals feeding the loads. Follow any wire, end to end. That is what a clean panel drawing gives you before you ever pull a conductor. Now, let us lay out a small one from scratch. Blank canvas. I search the symbol library and tap parts onto the grid. A breaker for the field feed. A box standing in for the PLC. A switch standing in for an input device. A lamp standing in for the output load. And a ground. These come from the free do-it-yourself pack the guest editor gives you. The dedicated PLC and sensor symbols live on the paid tier, but these shapes are enough to lay out the I/O. Then the wires. Press W, click one pin, click the next, and the wire snaps in with square corners. Move apart, and every wire follows. And here is something a plain drawing tool cannot do. Simulate it. I will open a ready-made control template, the kind of circuit a PLC output drives, already wired. There's a genuine SPICE engine inside the page. Hit Simulate, choose the DC operating point, and run it. Live voltages and currents land right on the wires. If a common were on the wrong rail, the numbers would tell you before a single wire got crimped. That is a check no paper drawing can give you. When the drawing is done, it has to leave the screen. One click opens the export menu. PNG is free, good enough to drop into a panel build sheet or a group chat with whoever is doing the install. Vector formats, PDF, SVG, and DXF sit on the paid plans. That is the honest business model, and I will say it plainly. This tool is ours. For clean I/O and panel drawings you can share and mark up, it is genuinely good and free to start. One last thing, because wiring the I/O is only half the job. Once the field wiring is drawn, you still have to write the ladder logic that reads those inputs and drives those outputs. If you want to build and run that logic itself, scan by scan, our sister PLC simulator does exactly that, and it is linked in the description. There is a full panel and PLC demo on this channel too. Draw the wiring here. Run the logic there. So that is how to wire PLC inputs and outputs, start to finish. 24-volt field supply. Inputs, red field devices through the input common. Mind syncing versus sourcing. Outputs, switch loads through the output common. Relay, transistor, or triac. And protect any inductive load with a flyback diode or snubber. Open the free editor and lay out your own I/O, a supply, an input, the PLC, and output. It is at CircuitDiagramMaker app. No install, no card. Subscribe for a new wiring video every week. See you in the next one.